Good morning, learners. Today we are going to study about the proofs of the three theorems. And what are these three theorems? The first one is this one. The subtended angle standing on a semicircle or on the diameter of our circle is a right angle. After proving this one, then we have the second one, in which the subtended angle is 1/2 of the measure of the central angle. And the third one is the subtended angles standing on the same arc are equal. The subtended angle or angles are the angles that can be found on the circumference of our circle. So this one is a subtended angle. This one is a subtended angle. This angle here is also a subtended angle. Angle here is standing on a semicircle. This is our semicircle. The angle here is standing on the diameter of our circle. Now we are going to prove that this subtended angle here, which is opposite of the diameter, is equal to 90 degrees or right angle. We have here the center of our circle at point O. Therefore, we know that this chord here is the diameter. Let's draw the radius from O to this one. So, radius from that subtended angle. So, this is now our figure. This radius is equal to this radius. So these two are equal, and also this one is also a radius. Therefore, this one is also equal to this one and equal to this one. So these three are all equal. Now, let us call or name this as angle A. And the other one is angle B. Now, let's have this triangle here. This triangle here only. We notice that we have two equal sides. Now, if we have a triangle with two equal sides, what kind of triangle is that? An isosceles triangle. If two sides are equal, that is an isosceles triangle. We have also two equal angles, the base angles. And where are these base angles? They can be found on the opposite of the two equal sides. So this side, opposite of this side, is this angle here. Therefore, this one is equal to the other angle here, which is opposite of this side. So this two angles here are equal, or let's go back here first. Now, we locate the base angles, and one of the base angles here is angle A. Now, the opposite of this radius here is where? It's here. So we're going to put here, it's also A here. See? This angle A here and this angle A here, they are the base angles of this triangle. So that's why they have the same letters A and A. Okay. How do you find this angle here? Let us find this angle here, class. How do you find this one? Now, in any triangle, class, the sum of the interior angles is always equal to 180 degrees. So we have A plus this angle must be equal to 180 degrees. So how do you find this one? What is this angle in terms of degrees? So we have A plus A here plus that angle there. Let us say that this angle is angle C, for example, only. So plus C is equal to 180 degrees, right? Okay. We combine like terms, so A plus A equals 2A plus C is equal to 180 degrees. Then we solve for C. This one, so C is equal to 180 degrees minus 2A. So that is our C. Now, can we replace the C here? So we can see it clearly. So I'm going to erase the C and I'm going to put this one as 180 degrees minus, I'm going to erase this one, minus the 2A here. Okay. Can you see that? This angle here is 180 degrees minus 2A. This is the angle here. Now let's have the other side. Okay, the other side. On the other side here, this is also an isosceles triangle. So we have two equal angles there, the base angles. Now one of the base angles here is this angle B. The other angle, which is also the base angle, is this one, class, because this one is equal to this one. Opposite of this side is this side. So we can call this one as angle B also. Now, how do we compute for this angle? Now, let us name this angle here as D. It's D because we use C here, we'll be confused. We'll use D here, angle D, temporarily. So, this is a triangle, and we know that the sum of the interior angles is 180 degrees. So, we are going to add here. So, we have B here plus B there plus the D here is equal to 180 degrees, right? Then we solve for D because we are going to replace the D there. So we have D here is 180 degrees, and then I forgot that B plus B equals 2B before we transpose, so you will not get confused. So when we have D is equal to 180 degrees, then minus 2B, right? So we are going to replace this D now, class, by this one. Here I'm going to put here, this angle here is 180 degrees minus 2B. This is 180 degrees minus 2A. The other angle is 180 degrees minus 2B. Now, what is this class? What is the relationship of our angle here and the other angle there? What is their relationship? They are supplementary angles because we have a straight line. So when we have angles, two angles in a straight line, these two angles are called supplementary angles. It means that the sum of these two angles is 180 degrees. So we are going to add this one, and this one is equal to 180 degrees. So here, we have here, okay, here, we have 180 degrees minus the 2A here, okay. Then we are going to add this one plus 180 minus 2b here, okay, is equal to 180 degrees. We add this and this, that this is a straight line, then we have 180 degrees. Now we combine like terms, 180 plus 180 is 360 degrees, minus 2a minus 2b is equal to 180 degrees. Now, we transpose minus 2a and minus 2b on the right. So we have 360 here, 360 degrees. We transpose 180 here plus, and minus 180 degrees is equal to, we transpose this 2 on the right side here. We have now positive 2a plus 2b. Okay, now we have 360 minus 180 degrees, that is 180 degrees, is equal to 2a plus 2b here. Can we factor it? We factor that one is equal to a plus b. We divide this by 2. We divide this by 2 also. So we cancel. So we have 90 degrees is equal to a plus b. When we add here angle A plus angle B, it is equal to 90 degrees. Therefore, this angle here is a right angle. So let us now prove the second theorem, in which the subtended angle is 1/2 of the measure of the central angle. Just erase the 180 degrees minus 2b here. But for this angle here, it is still 180 degrees minus 2a. Now, the central angle here, class, is this angle here. The subtended angle here is this angle here. Okay. So, we have here a straight line here. We want to find this one, and this one is the unknown angle. So, this is a straight line. It means that this angle and this angle, they are supplementary angles. Therefore, the sum is 180 degrees. So, I'm going to write here 180 degrees. We will just subtract the 180 minus 2a here. We just subtract this angle here, and we have that angle there, the question mark. Okay, let us put some angle here. For example, that is angle E, that missing angle there. So we have here a straight line. We subtract this one from 180 minus this 180 degrees minus 2a is equal to that angle E. So we have an angle E here, like that one. Okay, so we have 180 degrees, open parenthesis. So we have this one is 180 degrees. Negative and negative is positive, and we have 2a is equal to that angle E there. And then we subtract this one. So we have 2a is equal to angle E. Therefore, I'm going to erase now. I'm going to replace A because A is 2a. So this angle here is actually 2a. It means this one is a. That central angle is twice the measure of angle A. Or angle A is 1/2 of the measure of the central. This is the proof of the second theorem. So we have here our original angle, first figure. Now let us put I'll name this point here as point P, and name this point here as point K. Okay. Now, this one is, we are going to move point P down here. It's like moving this point P, and we are going to move, but this one will not move. Only this part here will move here. So it's like that one. So this one is point K, and this is our point P. O to this point here is the same. We will not move this up to here. This and this is the same. I just move the point P from here and here, and then I connect the K here, because that one's that line here. It will be with P. This is this line here, and this line, actually this diameter is, we have two lines here. We have coinciding lines here. This and this, they are coinciding lines. This one, no, this one. So we have here, we can see here clearly that this one is our subtended angle, and this one is the central angle. So if you are going to put this one, this is our A, and this central angle here is our 2A here. That's the proof there. It means that if our A is 40 degrees, our central angle there is 80 degrees. Okay. What about the third one? The subtended angles is something on the same arc. I like to draw another one here. I'm going to draw here and there. So this angle here is the same as the angle here. So this one is also A, because this angle here is standing here on this arc here, and this angle A here is also standing on the same arc. Therefore, these two subtended angles are equal.